Hi, everybody. This is Melissa Robinette, Mrs. Robinette, and I'm here today. We are going to be talking about evolution, or actually reviewing natural selection in terms of evolution, and then talking about the lab activity that we are going to be doing in class tomorrow. First off, let's review what natural selection is. This was the ideas that Darwin proposed after his voyage on the HMS Beagle. There are four principles that apply to natural selection, as you can see here from our notes that we did the other day. And there are three principles I want to focus on in particular. First off is that individuals in a population show variations among others of the same species. And the example that I used in class was the students in a classroom all look different. We can look around at each other and see that some people have straight hair, some people have wavy hair, some people have blonde hair, some people have black hair. The second principle is variations are inherited. So my brown hair I inherited from my mother and my father. You look similar to your parents is the example. And thirdly, the principle I want to focus on is variations that increase reproductive success will be more common in the next generation. So the example that we have here is if a fan-shaped tail increases reproductive success in pigeons, then more pigeons of the next generation will have fan-shaped tails. Whatever makes you successful in your life, whatever traits that you have will make you successful, you're more likely to eat. If you're more likely to eat, you're more likely to reproduce. And whatever those traits that made you successful, you will pass on to your offspring. So the second thing I wanted to review with you all is the three types of natural selection when it comes to the selecting of traits. So we have here, first of all, stabilizing selection. In stabilizing selection, if we have three varieties of traits, we have light coloring, medium coloring, and dark coloring. In stabilizing selection, the medium color is favored. And so what we see here in this graph is that the medium colored traits are being selected for, while the light and the dark, the extremes of the two traits, are not being selected for. In directional selection, there's going to be a shift. And one of the traits, either the dark, as you see here in this graph, or the light, this hill right here can also be over here instead of over here. So one of the extreme traits are going to be selected for. And this has to do with the activity we will be doing tomorrow in class, the moths in England. But finally, the disruptive selection is the third type of selection. This is when both extremes are selected for and not the middle extreme. So if we're looking at light, medium, and dark coloring, the light and the dark coloring are selected for, but not the medium coloring. Versus in directional selection, either the dark coloring is selected for or the light coloring is selected for. So now that we have cleared that up and we've reviewed this information, let's talk about the lab activity we will be doing. It's the peppered moth activity. And what we are going to know is how natural selection determines the differential survival of groups of organisms. And students will know variation within a species increases the likelihood that at least some members of a species will survive under changed environmental conditions. I have been saying that variety within a species is a good thing. It's a good thing that we all do not look the same. Because if there are changes in our environment that select the one way we look versus another, that can continue our species survival. Versus if we all look the same and the environment does not select for it, that could mean the extinction of our species. So some background information. The peppered moth lives in England, and it has two varieties. There is a light colored moth with gray spots, and then there's a dark gray peppered moth. In the early 1800s, the light colored moth was more predominant because the light-colored moth would blend in with the bark that it would sit on, not making it noticeable to predators. However, after 1850, the darker moths became more prevalent. Why is that? Well, Around 1850 is when the Industrial Revolution started, and coal burning factories started popping up, and the soot from these factories were coating the trees, making the dark gray peppered moths more camouflage with the bark and therefore less hunted. And the light colored moths started to become more hunted and decreased in numbers. So what we are going to be doing is we are going to be simulating this process. The materials that we have here is we have white background paper. White background paper is going to simulate the white bark pre-industrial revolution. And we are also going to have newspaper print bark. This is going to simulate the dark bark after the Industrial Revolution. Then we have squares. Well, the lab says squares, but I take it a step further and I actually punched out little butterfly or moth-shaped paper moths. So we have the light color moth and the dark colored moth. So we have different roles in our groups. One person is going to be the bird. Your fingers are going to represent your beak, and you must squint your eyes to represent poor eyesight as you hunt moths that are going to be situated on top of the bark. The timer can use their cell phone to time 5-second intervals of feeding of the bird. Then we have the recorder. That's going to be the person who's going to take down how many moths have survived. Not how many moths the bird has eaten, but how many are left on the bark. And then we have the reproducer. The reproducer is going to be responsible for adding new babies to the survivors. For each survivor, they are going to get one new baby. So the example here is if 3 white squares or white butterflies or moths are left, then the reproducer will add 3 more white moths. And everyone is going to have turn in their lab report, so everyone needs to copy down this table. This table is going to represent the population of peppered moths in England in the 1800s, pre-industrial revolution. So we have here 5 generations. Then we have the number of light moths at the start of the generation. We have the number of dark moths at the start of the generation. And then the number of survivors after each generation, which is what the recorder will write down. And the rest of you will get the information at the end of the lab. So here are the instructions for pre or early 1800s. You are going to lay out the white background tree, okay, in the for the early 1800 bark, and the reproducer is going to sprinkle 15 of the white moths and 15 of the dark newspaper moths on the white paper. You're going to spread them out, make sure they're not overlapping. The bird can be looking away. Once the reproducer has situated the moths on the paper, the bird can come, timer will be ready, and can squint your eyes using the beak and start feeding on the moths. The timer will say when time is up, and the recorder will write down how many moths are left on the paper, making sure to record how many are white and how many are newspaper. And the reproducer will come in and add the appropriate amount of babies to each survivor. You're going to repeat this process for 5 generations, hence the data table having 5 generations. You're going to then repeat this process, but now we are doing this in the in the 1850s when the Industrial Revolution was going on at its peak. But instead of using the white bark, we are now going to change the background to the newspaper print bark. Okay, and you are going to have a second data table that's going to look exactly like the first data table, except that the title is going to read Table 2, Population of Peppered Moths in England in the 1850s. So you're going to repeat this process for 5 generations, and you're going to take data. Then you are going to answer the discussion questions using your prior knowledge and this lab to help you out. Please feel free to review this video for any tips or hit me up on Remind if you have any questions. Have a great night and see you tomorrow.